Welcome back, everyone, to The Hannibal TV. Thank you, everyone, for joining us here on a Sunday afternoon. We have a special guest with us. Some of you may have heard about him recently, right, with a lot of news with our newest interstellar object that we have hanging around out in the vast areas of space. Our best friend here, and also ufology, right? He gives us a lot of tidbits on what's going on. Sitting in as on the advisory committee with the UAPDF, but he's known as a professor of science at Harvard mostly, right? That's what we all know Avi Loeb as well as a New York Times bestseller. Some really good books. One of my favorite is the one that you did on the extraterrestrial work with the first sign of intelligent life beyond Earth. I know you've also brought us a lot of information on past interstellar objects that we'll get into, but thank you so much, sir, for joining us this afternoon. How have you been?
Thanks for having me. Yeah, things have been quite busy with the new interstellar object that was discovered.
Yeah, and I kind of made a political joke today about it, and I know you've been making your rounds. We'll get into it. I said, you know what, Three Eye Atlas is no tail has formed yet, but there are concepts of a tail, right? So, alluding back to concepts of a plan by some of our politicians. But what do you make of this tail? Is it a tail? Is it not a tail? Is it maybe forming a tail?
No,
what do you make of that?
Currently, there is no evidence for a tail the way we see around comets. The best image we have was from the Hubble Space Telescope, and it shows a glow of light ahead of the object with no trail of dust or gas behind it. Since then, we had a bigger image of the object in carbon dioxide, actually, that shows a large cloud of carbon dioxide around it. And that cloud is symmetric. It doesn't extend the way cometary tails do. There is no evidence for a water cloud around it. So it's probably not a water-rich comet. And it's not clear that it's a comet because the carbon dioxide may be just ice that collected on the surface of the object. And even over a period of a year, the amount of material needed to be supplied for this cloud that is maintained around it is accounts to less than a millimeter thickness, a very thin layer, basically the skin of the object. The question is, what is the nature of the object under that skin? And this could be just dirt that collected on the surface, irrespective of its nature. It's not clear to me that there is any evidence for dust, because the object appears red, and some people interpreted that redness as being the result of a cloud of dust around it. But in order for the dust to redden the sunlight reflected from the object, the particles have to have a size comparable to the wavelength of sunlight. And if they had that size, they would immediately get pushed behind the object. Within a day, they would trail it in a beautiful cometary tail. And we don't see that. So I would be actually surprised if there is much dust coming off the object.
Sure.
And so we currently are not seeing the telltale signatures of water-rich comets. And the reason I was intrigued by this object in the first place was the fact that its brightness, if there is no dust, then most of the light that is reflected from the region around it comes from the object itself. And if you do the calculation, you find that it needs to be bigger than of order 20 kilometers in diameter. The latest data from the Spherex Space Observatory suggests a size that goes up to 46 kilometers, and that's huge. And the reason I found it surprising is because the previous interstellar objects, Oumuamua was the first one in 2017, and then after that there was a comet called Borisov. Both of them were on the scale of hundreds of meters. Okay. And if this object is 20 kilometers, it means that it's about 1 million times more massive than these objects. And we should have seen millions of smaller objects of the scale of Oumuamua and Borisov before seeing one as big as 20 kilometers. We haven't. This is the third one, so that will be
It's
quite
about
unusual.
Mount Everest, right?
Yeah, I mean, two small ones and then a giant one. And moreover, there is not enough rocky material in interstellar space. I wrote a paper about it on the 4th of July when my wife took me on vacation. I just couldn't resist writing a paper saying, if you just estimate how much rocky material there is in interstellar space per unit volume, even if you package all of it in 20-kilometer rocks, you would expect one of those rocks to arrive at random to the inner solar system once per 10,000 years. And we have just monitored the sky for a decade. So how come we observe such a giant rock? And so then it led me to suggest either this object is much smaller and we are fooled by something like a cloud of dust around it, but now we don't see that dust. There's a cometary tail. Or the alternative is that it didn't move on a random trajectory. The trajectory was targeting the inner solar system, meaning that perhaps it was designed by some intelligence, but it's a technological object. And in that case, I looked at the orbit. The trajectory of this object appears to be aligned with the plane of the planets around the sun to within 5 degrees. And the chance of that happening at random is 1 in 500. And moreover, it comes very close to Mars, Venus, and Jupiter. And if you just follow the trajectory and just not even change it, but just arrange for a random arrival time, the chance of that alignment with the planets would be 1 in 20,000. So that suggested that it may be technological in origin. And of course, the way to settle it is by observing it, getting as much data as possible as it gets closer to the sun. And, if it, right now I give it a rank of 4 on a scale that is now called the Loeb scale that I invented in July for this object, where 0
is a rock.
Implies, a rock, a natural object. 10 is an object that is definitely technological, that may be a threat to Earth. For example, if the object maneuvers or broadcasts a signal or emits artificial lights. And we don't have those technological signatures as of yet. I gave it a 4 as of now. But if you go down the street and you see a car approaching you and you give a 40% chance that it will run over you, then you better watch that car. And so my point is simple. We should keep our eyes on the ball and monitor this object, because if it happens to be technological, the implications could be huge for the future of humanity. And I'm not just talking about us recognizing that there is another civilization in our neighborhood, but also it could be a threat because we don't know the intent. If you have a visitor to your backyard, the visitor, first of all, it's an imminent threat. You have to decide what to do about it, because that the visitor may enter through your front door. And we've never contemplated such scenarios before. We thought about the radio signals that we might receive from far away, thousands of light years away, where you have the leisure of responding after a while. You don't need to worry about an immediate risk from that. And so it will open up a completely different perspective of that could lead, for example, to a decision to employ an array of spacecraft in orbit around the sun that would protect the Earth, basically monitor any object that enters the solar system from outside and try to figure out if it's a threat to humanity. And we can use a set of interceptors or monitors that take images of incoming objects to tell us whether any of them might be a threat. And we just haven't thought about such existential threats. We often talk about artificial intelligence as a potential threat, or a global climate change, or an asteroid impact, but we don't discuss alien technology.
Yeah, and we saw you, what was it, about 3 months ago when you presented to Congress with the UAPDF. They're sitting down with Representative Burleson, Burchett, Paulina Luna. You gave about a 30-minute presentation. At that point, we didn't know much about 3i Atlas, right? You presented mostly
No,
with
it was not found.
it was not found.
No, it was discovered on July 1st, 2025, and this briefing was May 1st,
So you
2025.
just missed it. I mean, you had one more piece of information we could have shown them, right? But you
Oh,
definitely had the Oumuamua case, and you showed them how 91% of that surface would have been flat, right? Based on when the way it reflected light when it was tumbling, we were able to surmise that. So I'm wondering, are we making any formations of this object yet to where you can give us some numbers around, just like you said with the Oumuamua, it's probably 91% flat, right?
yeah, well, these are very different anomalies. That Oumuamua was anomalous in terms of its shape, as you say, most likely flat, and it was also pushed away from the sun by some mysterious force without showing any evidence for cometary evaporation. There was no gas or dust around it, yet it was exhibiting non-gravitational acceleration. Now, this object is very different. 3i Atlas, the third object, is very big. That's one anomaly that you cannot accommodate easily with a rocky reservoir of material in interstellar space. And then, in addition, it has an anomalous trajectory. And also the great advantage of this object is that it's now entering the solar system, so we can actually get more data on it. With Oumuamua, it was leaving the solar system when we noticed it, and we didn't get enough data on it. So my hope is indeed that we will observe it with all the assets that we have, not only on the ground or the telescopes, but also in space. There is a camera near Mars. It's part of the Mars Reconnaissance Orbiter, and it's a half a meter in diameter aperture that could resolve 30 kilometers at the distance that the 3i Atlas will be on the 3rd of October when it comes closest to Mars. And so I encourage the team that operates this camera to use it. I also wrote a paper about using a spacecraft near Jupiter that is called Juno. It could have potentially intercepted 3i Atlas if it had enough fuel, if it had all of its initial fuel. But even with much less than that, it could get close to the path of 3i Atlas when it comes closest to Jupiter on March 16, 2026. And I actually wrote a paper about this, and because Juno was supposed to crash into Jupiter and in mid-September 2025, and I suggested just pushing it away from Jupiter instead of into Jupiter so that we can use it to learn more about 3i Atlas. And a day after I wrote this paper, I had a phone call from Congresswoman Ana Paulina Luna, who wanted me to give her an update about 3i Atlas. And I mentioned the fact that Juno can be used. And so she very generously decided to write a letter to the head of NASA, Sean Duffy, who is the transportation secretary and the current interim director of NASA, encouraging NASA to actually look into the possibility of using Juno or other assets. And I'm very grateful to Congresswoman Luna for doing that. And my hope is that we will use all of our facilities to learn more about 3i Atlas.
Has anyone, and I'm going to ask you the outside curveball question of remote viewing. Has anyone in our government offered you remote viewing assets that would be able to look at the rock? We hear about this, those of us more in the community than in the community of studying the cosmos and studying space. Those of us who are paying attention to everything that we're hearing out of UAPDF. There's some folks who are in UAPDF that are on the advisory board with you that believe that there are people who have the ability to remote view objects as a CIA project. Has anyone offered that as like, well, let's go up there and take a look at it and get some answers for you?
No, I should say that would be fantastic if astronomy can be done by remote viewing, because we are trying, it costs a lot of money to build our biggest telescopes. And
right?
if we can, instead of using telescopes, can use other methods, that would be amazing. But as far as I know, that was never attempted. with respect to space objects that are very far from Earth. And I think 3i Atlas will get close enough for us to learn a lot about it in the coming month or two. As it gets closer to the sun, it will get brighter, bigger in the sky, and also warmer. We will turn on the heat on 3i Atlas, and
Sure.
that would allow us to tell if it's a comet, because it should evaporate. We should see a beautiful cometary tail, or the typical characteristics of
Late October, right?
Well, October 29th is when it's coming closest to the sun, and actually the Earth would be on the opposite side of the sun, and that's unfortunate. We won't be able to observe it from Earth, but other space telescopes, or facilities that we have in other locations could observe it. And of course, if it does a maneuver, this is the best time for it to actually use gravity assist from the sun. That's what we do with spacecraft, that when they get closest to the sun, we can boost them by giving them a thrust and taking advantage of the gravitational force from the sun. And the same may happen with 3i Atlas if it happens to be maneuvering, or it releases mini probes as a mothership around that point. We won't be able to observe it from Earth, but we could potentially see the implications of that. And I asked the research team of the Galileo Project to check if there are any anomalous objects that appear after October 29th. Of course, if the object itself maneuvers in ways that cannot be understood just by the law of gravity, then the stock market may crash. I had a fan that was reading my essays. I write an essay almost every day or two on medium.com. You can find a lot of updates there. And he said that he decided to trade options on the volatility of the stock market with an expiration date of October 29th, just in case this object ends up being technological.
Yeah, and we're getting a lot of questions here in the chat, live chat. We have a lot of folks on. Thanks, everybody. Be sure to like it if you enjoyed the discussion. We're getting a lot of questions about the signals, and you talking about it not emitting a signal, not as of yet. So we're getting some questions on that from the fans listening along here, such as Gene Sticko here, who says, is it only a distance that keeps you from reading the signals of whether natural or not at this point? We also had another question about the signals from Jock the Hydra. It says, are we certain it isn't emitting signals in some way and we haven't thought to look for? So, is there a point where it comes close enough to where we would know that? Or
we could have detected the signal if it were transmitting it. The question is whether any of the observatories that are capable of detecting.
So you believe we do have the tech to be able to observe from the distance it's at right now? If it were.
Well, it depends on the power of the transmitter, but we have radio telescopes. We have a lot of optical telescopes and even X-ray and gamma ray observatories that can be looking for a signal. But so far, nothing was reported. I don't know if radio telescopes are listening.
Yeah.
Because if it's a natural object like a rock, nobody expects a radio signal. But nevertheless, it's worth checking. So the data that was released so far involves images. We can't really resolve the object itself because it's so small. It looks like a point source, even in the Hubble image or in the most recent SphereX image. But we know that on August 6th, this object was observed by the Webb telescope, and that is the most interesting data to look forward to. But it wasn't released yet. The data is still under wraps, and it's not clear what exactly is the nature of the data.
Yeah, let's talk about that, because I was going to have a question for you on that. It's my belief that disclosure will not come from Congress. It won't come from catastrophic disclosure where the alien presents itself to us. I believe disclosure will come from that platform, the James Webb Space Telescope. But my worry is suppression. What are we dealing with there? Can you help us understand data gathered by that platform? What kind of back channeling exists there that we're going to have to be worried about not being, data not being presented to us off of that platform? Because, I mean, you just mentioned it.
Well, no, I think you shouldn't worry too much because the way the data is handled is completely open and according to procedures. So, in principle, there are people who propose to use the James Webb Space Telescope to observe objects like 3I Atlas, interstellar objects. So they got time to observe it, and that was the data collected on August 6th. And according to the rules of the Webb telescope, they have 3 months during which the data is at their disposal. They're not obligated to release it. That's completely understandable when you deal with observing, let's say, galaxies at very large distances. Nothing much happens over a few months. But in this case, the reason that we really want it out so quickly is because the object is moving. And in 3 months, it will be moving out of the solar system. We want to know as soon as we can what can be learned from the Webb data so that we can design other observations as follow-ups. And that's why the urgency. But the rules of the Webb telescope allow whoever collected the data to keep it to themselves. Now, they could have already released it because the Hubble data was released within a couple of weeks, and the SphereX data was released within about a couple of weeks, and we could have had the Webb data released, in a scientific paper within a couple of weeks, unless, there could be also some challenges, scientific challenges that they are encountering. For example, the field of view of the Webb telescope is rather small. It can look only on about a few arc minutes on a side, and that may be not big enough for them to calibrate the background flux of infrared light that they are detecting, and so they can't really tell if there is a cloud of emission around the 3I Atlas maybe. And also there are obviously background stars in that image that they're taking, and they need to somehow separate the emission from 3I Atlas from background stars. And these are challenges. And I would say as of now, the delay is still reasonable. If it's a matter of weeks, if we don't see a release within a month, then it would start looking as if they have an issue that they cannot resolve. But eventually by November, November 6th, the data will be out no matter what, even if the team that is analyzing it has difficulties, everyone will be able to access that data.
Yeah.
So don't worry, there is no way by which, it's not like government data that is classified. In this case, it's available to the scientists that are currently looking at it. It's just that it's not available to the public until they decide to make it available or until the 3 months expire.
Sure. Thanks for clearing that up. Yeah. With propulsion, for example, and you're talking even, you mentioned maneuvers or any type of maneuverability or change of trajectory. We did have a question from UAP Reporting Center on X. He says, if 3I Atlas were under propulsion, what signature would you expect from a nuclear-powered system at such distances, and is there any existing data hinting at that?
Well, so the obvious signature would be non-gravitational acceleration. If you have propulsion system, you should see deviations from the trajectory that you expect just based on gravity. And that was seen in the case of Oumuamua. We saw a deviation from the trajectory expected by gravity, but we haven't seen any rocket effect from a cometary evaporation. So that's why it was anomalous in my view. And I suggested that it's being pushed by reflecting sunlight, like some technological objects that we launched to space, appear. And in fact, 3 years later, the same telescope in Hawaii discovered an object that is being pushed away from the sun by reflecting sunlight, and it ended up being the upper part of a technological object, a rocket booster that was launched by NASA in 1966. Yeah. It's called 2020 SO. So that was in the case of Oumuamua, but in this case, it could be actually a functioning device that would maneuver not because of reflecting sunlight, but because it has an engine as the question is alluding to. And in that case, the non-gravitational acceleration could be much bigger and much more anomalous than reflecting sunlight, and we should be able to detect it. I haven't seen an analysis as of yet of the best data we have on the trajectory and what are the limits on non-gravitational acceleration. But I would be most interested in what happens when it comes closest to the sun, because that's the place where you expect to have maneuvers in order to get gravity assist from the sun. So let's see if there will be anything.
Yeah. Well, as we talked about there about 3 months ago when you were presenting to Congress with the UAPDF. So you're there with Tim Gallaudet, right, and others, right? Lou Elizondo was there, Chris Mellon. You spoke of $1 billion to help and to start digging into this matter of looking for objects. So you're there with Tim, though, right? And you are a man of the sky. Tim is the man of the waters, right? So you kind of have a battle of the mediums here.
Oh no, I actually went to the ocean, the Pacific Ocean, in search for materials of an interstellar meteor back 2 years ago. And
right, they can end up in the water. Yep.
Yeah, so when you have an object colliding with Earth, most of the Earth, more than 70% of the Earth is covered by oceans, and so there was an interstellar meteor that was spotted by U.S. government satellites, and I went after the materials of it a couple of years ago, and there will be a Netflix documentary showing that expedition. So check it out in early 2026.
Okay. Well, and if they were to come out and say, okay, we have $1 billion ready, but we're trying to decide if we spend it on space or sea. We only have about 25% of our oceans mapped, according to Tim Gallaudet and others. What do you say to those that think the threat is more us not understanding our oceans and what's going on Earth rather than out in interstellar space? What would you say to folks who challenge that 1 billion and say that 1 billion should be spent, assuming only 1 billion was available? I'm just saying hypothetically, if only 1 billion were available, how would you make a case for interstellar research winning over oceanic research?
Well, now we are entering a new era in the study of interstellar objects, because the Rubin Observatory in Chile is expected to find every few months a new interstellar object. The question is really whether we will get a wake-up call, whether we will see objects that are really anomalous. And I would argue that we should then spend a lot of money after that, because there will be clear evidence that we're missing something.
Yeah.
With respect to the oceans, the question is, what can you do with different levels of funding? And we should look obviously into that. So in both cases, I would argue, let's make a plan and see how much useful information we can get from investing different levels of funding for the two frontiers. No, it's not one or the other. It may be both of them. But the cost may be quite different, because to put, for example, a spacecraft usually costs much more money than to put ROV, a remotely operated vehicle, on the ocean floor. And so I would approach it from the level of funding needed to acquire important insights on both frontiers, actually, and not just one.
Understood. So looking into your background, Professor, you also are shown to receive a PhD in physics from the Hebrew University of Jerusalem in Israel at the age of 24, correct?
Yes.
So what do you think of when you hear Israeli members of consequence like Haim Eshed who come out and they say, UFOs, aliens are here, and they're asking us to hold off spreading the news because humanity isn't ready yet? You don't hear a lot of other governments make waves in this topic, right? Other than U.S., and now we have Haim Eshed with the Israeli government. So I just wondered what you thought about that.
Well, he said that during an interview that he gave to an Israeli newspaper several years ago, and I've never discussed it with him. He refers to my work, actually, as it turns out, in his book. And I spoke with people who know him, and they said that prior to making this statement, he was a very reliable source of information, very reliable person.
Hmm.
And the question is whether what he says, is really corresponds to something real or not. And he didn't provide any direct evidence, a paper trail, for example, or some direct evidence. Maybe we'll hear about it in one of the future congressional hearings. We'll hear about, but it's the way I look at it is it's all about the evidence. It's not so much about the stories that people can tell us. I want to see direct evidence, and if people witnessed something within the U.S. government, let's say, then maybe one of the future congressional hearings will reveal it. And I'm not talking about people who talk about projects within government, but actually were witnessing whatever the government may have. And I was never exposed to that, and I don't know if it's real or not. On the day before my congressional briefing, I visited. I was invited by the All Domain Anomaly Resolution Office and to visit and have a discussion with them. And I asked them. They looked at hundreds of cases from the past, and I asked them, did you notice anything unusual? And they said, no, nothing really, but there are some reports from FBI agents, but other than that, all the data that we looked at could either be explained as human-made, or there is not enough data for us to figure out what it was. And so it wasn't clear to me that the AARO will bring us closer to any revelation. And because a day later in Congress, the next to me was Eric Davis mentioning that the government has a dozen craft and with pilots and so forth. And I have to decide who to believe. On the one hand, a day before I hear there's nothing within government. They claim they can access everything, and then a day later, Eric Davis says that he was in government and knows about these things. So you just cannot decide what to believe unless you see the actual evidence. So Haim Eshed says something, but I want to see the evidence before I trust any of those stories, because people can say a lot of things, but, we need to verify that what they're talking about is real.
Yeah, and you there presenting with the UAPDF, we have a lot of fans asking questions about that. There's been some, change in those who are on the board and involved in UAPDF since that hearing. What do you make of any of the comings and goings of folks, Carl Nell, Lou Elizondo, people kind of coming and going? We're hearing news and chatter of their different camps behind the scenes saying some people are not as forthcoming with why they're there, what their intentions are. Maybe they're not being somewhat disingenuous. Do you get involved in any of that, or do you have any opinion on what's going on inside the UAPDF, or are you just kind of...
Not really. I'm I'm doing my science most of the time,
Okay.
And I really don't care so much about interpersonal relations within that organization. I really see the value of their activities or anything done in Congress only in case there is some, material that is of extraterrestrial origin or some knowledge that we are not aware of, that I can help government figure out. And that's really the only reason for me to be part of that. Otherwise, as a scientist, I can observe space, the sky, and with the Galileo Project and the 3 observatories that we have in Massachusetts, Pennsylvania, and Nevada, we're monitoring a few million objects a year, analyzing them with machine learning. That's the scientific approach. And if we see any unidentified objects, you will know about it. And actually, within a month, we should have the ability to triangulate, meaning measure distances to objects, which we didn't have before. And that would be really a phase transition for the Galileo Project. And we can then decide whether an object is performing outside the envelope of human-made technologies. And so the way I see it, it's all about the evidence. And of course, the US government had the more time to monitor the sky over decades, so they may have something that will take me a while to learn about by myself. And in that case, I'll be delighted to help them figure it out, but I was never informed about such a thing.
Yeah. So when you were on with Joe Rogan, you mentioned the situation with Giordano Bruno, who was burned at the stake in 1600 for, heresy against the Catholic Church. You know, a lot of that was based on his cosmological views, right? And it was seen as blasphemies. Do you think that we will still run against that today? Let's say if October 29th comes around and a certain type of propulsion is discovered on 3i Atlas, and we start making some very scientific assumptions based on what we're seeing and observing, are we going to have this fight eventually, even the same fight they were having back in 1600? Now, we may not be burning people at the stake today, but metaphorically we still do. So are we still in that same boat where we're going to have to answer some deep religious questions?
No, I think what happens now is obviously on social media, people are getting canceled sometimes, or there is a lot of negativity, toxicity against even scientists that deviate from the beaten path. I'm trying to consider possibilities that other scientists find really controversial and difficult to believe. But the point is, science is not about belief. It's about collecting data and evidence that will convince all of us. And the only way to avoid that is by adopting the approach of the Vatican. When Galileo Galilei observed the moons to Jupiter through his telescope and realized that not everything revolves around the Earth, the Vatican said, you will not be able to communicate that to the public. They put him in house arrest. And the mistake they made was not to say, oh, we have more money than you do, we will build a bigger telescope and prove you wrong. Because if they were to do that, they would have realized that he's right. And that they would have corrected course very quickly. Instead, what they did was 350 years after he died, they made an announcement in 1992 that he was correct. So that was really embarrassing for the Vatican. But you can now say that in retrospect, the lesson is that, even if you don't believe something, as long as you try to collect data to disprove it. So if my colleagues, for example, do not like what I say and they want to show beyond any reasonable doubt that the 3i Atlas must be a comet, that's great, because they will collect a lot of data, and if it's not a comet, they won't be able to shove it under the carpet of traditional thinking, because all these anomalies will be there. The only way to maintain our ignorance is not to collect data. So, for example, in the context of UAP, for many years, we had to just rely on what the government tells us. But now the Galileo Project is collecting its own data. We don't need the government to tell us what our cameras are seeing, because if there is something extraterrestrial, we'll be able to tell. Anything terrestrial, anything human-made, is boring as far as I'm concerned. I don't care about it. But the point is that with data, if you collect it, eventually everyone would agree to it, because it's impossible to ignore it. And so my hope is that with 3i Atlas, if it turns out that the object maneuvers, if it looks like technological, it would be crazy for anyone not to accept that. What may happen is that all these scientists that now say, it's nonsense and we shouldn't even consider that possibility, after this possibility is realized, they would argue, oh, we thought about it before. It's not the first time that someone suggested that. And in fact, we were quite aware of that possibility. And there is nothing really new about it. And in fact, we were discussing it a long time. Other people were discussing it. There is nothing new. And, that's human nature. I don't care about it. I don't care about what people say and how popular an idea is. Whether if we have a neighbor, it doesn't really matter what we say to our family. We can say we don't have a neighbor, but the neighbor will still be out there. And just the same way that the Earth continued to move around the sun for 4.5 billion years, irrespective of what the Vatican said.
Yeah, and we do get questions about that. We had one, and you're answering some of that, which was, questions we get commonly about Avi Loeb is, your peers in astronomy. Why do they not appear to be taking it as serious as you are? Is there just a lack of interest in the data collection?
No, it's
Is there a lack
the,
of curiosity or?
yeah, I would argue it's a lack of curiosity. That's reason number one, because experts, and in particular comet experts, they have their self-esteem and their recognition, their stature, professional status based on past knowledge. So they have been for decades monitoring rocks in the sky, and they would not take the risk of considering anything other than icy rocks. Even when Oumuamua did not look like any of the icy rocks we saw in the solar system, they called it a dark comet, meaning it's a comet where the cometary tail is invisible, which is very much like the story of Hans Christian Andersen, where the adults in the room say the emperor has clothes, you just can't see them, they're invisible. They say to the kid, even though the emperor is completely naked. And so that is the tendency of experts to always argue, oh, if you can't see something that we expect, then it must be invisible to you, but it exists. So they call Oumuamua a dark comet. That will be the approach until you have so much data that they cannot insist on that. And so that's one reason that experts subscribe to past knowledge, because their own self worth is based on that. They created echo chambers that just say the same thing again and again and again. And if you are challenging that, you are putting it at risk. The second aspect is that the public cares a lot about what I say. There were I didn't do any outreach to reporters. They just reported about my work, and the subject became viral. Right. And then what happens is all these people who are bloggers or YouTubers, they put all their time in getting as popular as they can with their audience. They suddenly see me becoming popular, and they are jealous about it. And that includes some of my colleagues in academia, and they're just jealous of the attention that it gets. Now, I didn't ask for it. The early reports about the work that I'm doing, the reporters didn't even consult with me. They just wrote things, and sometimes they exaggerate. They don't even say what I'm actually saying. And you can find what I'm saying by reading my essays on medium.com or listening to my podcast. And so at any event, that is a second aspect. That is one of the strongest forces in academia, jealousy.
Oh, sure. Yeah. And I mean, that's why I think that question comes up a lot is, in the community of ufology, everyone wants to talk about who's out there to make money, who's out there to sell a book. We had Paulina Luna say that she had some people miss a skiff because they just want to come there and sell a book. That was quote from Paulina Luna.
By the way, what do you? I put essays on medium.com. I don't make any money out of that, and that's a very I put since 3i Atlas was discovered, I put 44 essays over the past month and a half. 44 essays. It's a lot of work on my behalf. Also writing scientific papers. Sure. I don't get paid based on the scientific papers that I write. I don't get paid based on the essays that I post, and I don't get paid for my leadership of the Galileo Project. It's just things that I do because I'm curious about these things. So, and the books that I wrote were just to disseminate the information to the public, to just let the public know about what I'm doing. And I didn't make a lot of money out of my books, and this has nothing to do with making money. So this activity that I'm engaged in, where I communicate with the public, is because I believe it inspires the public, and the public cares about this subject. And over the past, few days, I was, for example, interviewed by The Times in London. The reporter messaged me afterwards and said that he read the story that he wrote to his children, and they were completely fascinated by the story for half an hour, and they are now interested in becoming scientists. I got an email from a pilot of the U.S. Air Force who said that the title of his message was "Because of You," and what he meant is that his children are now talking about being scientists and talking about aliens all the time, just because of me. Okay, and I see that as the biggest compliment, because if I can inspire young kids to be curious and enter science as a result of that, then I accomplished my goal, because I don't have any hope that my senior colleagues will be more curious than they are. They would argue that everything in the sky is rocks, and I regard that as the Stone Age of space exploration. Not everything in the sky is stones. We launched technological gadgets, and I expect other civilizations did. And the only way for us to figure out if any of those gadgets arrives at our backyard is to monitor the sky and do the scientific research related. So that's what motivates me, just learning about this subject, and nothing to do with making money out of it.
Yeah. And we've also had people that want to know that when 3I Atlas is getting closer to the sun, are there completely natural causes that would cause it to change maneuver, which would be it heating up, gases being emitted that would send it into a different trajectory? I think a lot of people think it changes direction, so it automatically has to have a conventional engine of some type, right? But aren't there natural causes that would cause it to change course?
That's exactly the rocket effect that comets have when they evaporate. But when they evaporate, we can actually measure the mass loss rate and the speed of the gas that comes out of them. Think of it as gas coming out of the exhaust of a jet plane or of a rocket. And if you know how much momentum it gives to the rocket or the jet plane, just by measuring the properties of the gas, there is momentum conservation. I once went on an airplane, and I estimated while waiting for the airplane to lift off, I estimated, how much fuel does it need to burn in order to expel gas at some characteristic speed that will give it the necessary thrust to reach the destination in a given amount of time. And I calculated it, and it turns out very close to what is really used by an airplane. So it's just momentum conservation, and if you have an object in space, there is no friction with an atmosphere. The space is empty. So if you know how much momentum is given to the object by its evaporation, because you can see the gases coming off it, then you can actually calculate how much thrust it gets from that evaporation, and that would be non-gravitational acceleration, like the rocket effect. But the point of the matter is that if you don't see it emitting a lot of, let's say, material in a cometary tail, and nevertheless you see it maneuvering with a much bigger non-gravitational acceleration than you would expect based on what you see, then you know that there is something else going on. Now there might be an engine or some propulsion system, and it depends what is the method of propulsion. There are many ways to propel an object. So what I'm most interested in is, as it comes closest to the sun, it may well develop cometary evaporation, and we could then figure out how much thrust and non-gravitational acceleration it would have acquired from that. But if it does behave in ways that are very different than you expect from that, then there is something else. And just to give you an example, suppose it has an engine, then it can maneuver in a direction that is completely different than the gases usually evaporate in the direction of the sun, because that's the hot side, that's the sun-facing side. But it can, if it's an artificial technological object, it can actually get the momentum boost in any other direction. It has nothing to do with the direction of the sun.
Okay. Yeah, that makes sense. Do you have time for one more question?
Yes, one more question.
Let's do one more. And this one kind of deals with Dr. Villarreal's transient research that she's doing. Have you looked into any of that with your connection to Harvard and the Menzel gap? And specifically, again, getting into the rocket effect, could an object be there one moment and not the next because of some propulsion that befall the object,
I think it's a very interesting line of research. I haven't looked at the data myself. And the reason is that I'm worried always about the historic data that was recorded on photographic plates. When you go back to, the 1950s or earlier, before, we launched the satellite, the method was photographic plates, and there might be all kinds of artifacts that it's just because of the recording method that you might have some streaks that would appear as lights, and they're not real because they're just related to the photographic plate material. And that's what I would be worried about. And I would believe something for sure if it was observed by two different telescopes, because the chance of a photographic plate in one telescope and in another showing the same source of light is extremely small. But if I just have data from one telescope recorded on photographic plates and I see a one-time phenomena, I would never be sure that it's not some artifact of the recording method. And that's what worries me about historic data. We can't verify it easily. And of course, if the same objects exist today, then we should be able to see them. That's what the Galileo Project is aiming at. So I spoke once with a historian and I said, look, I'm not so excited about historical events because there are all these questions. We can't really visit those events and figure out what really happened. But with respect to instruments, say, of the Galileo Project or the Rubin Observatory, I can now, if I see something anomalous, I can search for more objects like it. I can verify and double check that we are seeing something real. I can look at it with multiple instruments from different locations. And so for that reason, I very much prefer to collect new data than to rely on historic reports. And that's basically the narrative of the Galileo Project. So think of me as a kid that asks difficult questions and wants to answer them by my own data rather than listening to stories that the adults are telling me.
Yeah, absolutely. Well, thank you so much, sir, for coming on with us, helping us understand what's going on. We read a lot of headlines, right? And a lot of people love to read headlines, but not read a lot of the information and the data. So definitely thank you for coming on, breaking it down for us. You did all that without no sips of a drink or coffee. I took about 5 sips of my drink and coffee, so that's pretty impressive.
Before I spoke with you, I had a filming crew in my home that just came and recorded the session with me for an hour. And then immediately after that, I had an interview for a podcast from England.
Nice.
And then I joined you, and I didn't have a drink since lunch. So anyway, but I'm sort of a long distance runner. I jog
Nice.
every day for 3 miles before sunrise. And I actually had a soccer match that we have once a year between the students and the faculty a week ago. I did my best. I scored 2 goals, but the students won 3-2. But I'm still quite physical. I enjoy sports because it's real. It's physical, and that's what I'm trying to do also in my science, to look at things that are real and maybe will reveal something we haven't thought about before.
Absolutely. Well, thanks again for your time this afternoon. Thanks all the fans for joining, all the questions, and thank you again. I wish you well in Copenhagen. I know you're headed out.
Thank you so much. Yeah, I'm visiting the Niels Bohr Institute there and giving a lecture about the universe. And then also visiting Brussels on the way back for a group of high net worth individuals that are really excited about this line of research. And by the way, the reason I'm speaking to a lot of those people is because the research is quite expensive and we need funds to support it and make progress. And so my hope is that in the coming years, thanks to those funders, those donors, the Galileo Project will be able to make advances.
Thank you.